Dynamic lighting, considered in the lighting tutorial, ensures that all shadows from light sources are rendered correctly in real time. This approach implies that geometry of your scene is rendered one more time each frame to calculate shadows for each projected light, or 6 more times for each omni. Using multiple dynamic lights in the scene and calculating shadows for them on the fly may cause a performance drop, especially when the scene contains complex geometry with lots of polygons. Besides, it can be a terrible waste of resources when most objects and lights are static. The Static Shadows feature, introduced in UNIGINE 2.8, enables you to replace dynamic shadows and use baked ones for static geometry, thus reducing rendering load and significantly improving performance. Let's take a closer look at this feature using the sample included in the light section of the samples demo package. The scene contains numerous polygons and multiple light sources. Let's enable the FPS counter and rendering performance profiler to check out resources consumption. Right now, there are 63 dynamic shadows in the viewport. We can see it in the profiler stats. It's over 500,000 triangles rendered in the viewport each frame. Apart from rendering into the viewport, all the geometry in the scene is also rendered multiple times into shadow maps. So the number of triangles rendered into shadows, and therefore the total number of triangles rendered in the scene, is huge, which results in low performance. We've got a scene containing primarily static objects that are lit by stationary light sources, so we're simply wasting resources. We can use light sources with baked static shadows instead and boost the performance. Now, there are no more dynamic shadows in the scene, and we have the triangles rendered only to the viewport. With baked shadows, our scene became much less consuming than it was before. If we add a moving object with a dynamic light source, like this car, the number of rendered geometry will increase as dynamic shadows are cast from the car's headlights. But the car itself casts no shadows at all because of the static environment. Although this setup is the best for performance, it does not look realistic. To fix this, we can switch to the mixed shadow casting mode and get our car correctly integrated into the static surroundings with the same high performance. Baked and dynamic shadows are correctly blended together and provide huge optimization to the scene. Now, let's learn how to do that. So, how do we use static shadows? First of all, each of object's surface has the shadow mode parameter, defining whether it casts static or dynamic shadows. All analytical light sources, including projected, omni, and world ones, have the mode parameter defining whether the light source is dynamic and produces real-time shadows cast from all objects. This is the most consuming setup, or it is static and supports baking of shadows. It looks like nothing has changed as we switch to static mode. However, now the light source keeps its shadow map as the depth texture asset baked with the specified resolution. This significantly improves performance by skipping the unnecessary stage of rendering static geometry into the shadow map each frame. The mixed shadow casting mode implies that shadows from this light source are cast by both dynamic and static objects. The shadow of the dynamic ball works fine, unlike the shadow of the static one. It is baked now and does not follow the object as we move it. We can use the Bake Lighting tool and rebake it anytime we need to restore visual consistency. When a shadow-related parameter of light source, for example the resolution, or its transformation is changed, the shadow map is rebaked automatically. One more huge advantage of the mixed mode is that both dynamic and static shadows accurately interact with each other, shading any object that appears in their area of influence. So you can freely combine both types of shadows in your projects, integrating dynamic shadows into an environment composed of static objects. We can also change the shadow casting mode to static and thus disable dynamic shadow casting from the light source. Check out the table that shows all possible variants of shadow settings for both objects and light sources. Note that dynamic light sources provide dynamic shadows only. A static light in static shadow mode provides only baked shadows cast by static objects and ignores dynamic ones. For a static light in mixed shadow mode, both types of shadows are rendered, baked, and dynamic. The world light source works the similar way, but its shadow system uses shadow cascades. Let's enable the corresponding helper to visualize shadow cascades. In the dynamic cascade mode, shadow cascades are built dynamically relative to the camera's position and provide different shadow details depending on the distance from the viewer. We can adjust the size of each shadow cascade and thus configure the detail level of shadows. In the static mode, shadow cascades are baked and have their area defined by the light source's position. This mode can be used as a performance optimization technique for scenes with a small active area. We can make 2 shadow cascades and configure the size of the area by adjusting the height, width, and the ZFAR parameters the same way as for an orthographic projection. Changing any of these parameters causes the depth texture to be rebaked immediately. And we've got the walkable area covered with high-quality shadows and distant surroundings covered by the low-resolution cascade. Another possible use case is to cover the whole area with a single shadow cascade, using ultra-high 16K resolution for the baked shadow map. It provides fine quality of shadows while keeping performance high. However, mind the video memory consumption, as such a texture takes a lot of it. Thanks to this technique, UNIGINE can handle huge numbers of light sources using static shadows while keeping high performance. While building your scene, decide and specify which objects and light sources must be dynamic and which of them can be turned to static. After that, you can simply bake shadows to get a high-quality result. It is important to pay attention to shadow texture resolution and keep it at a reasonable level to avoid exceeding video memory capacity. Track video memory consumption for all baked shadow textures in the scene by using the Rendering Performance Profiler tool. Keep in mind that a single 4K resolution depth texture for an Omnilight takes about 200 megabytes. Copying such a heavy texture while blending it with dynamic shadows in the mixed mode takes time and may significantly affect performance, so using 4K resolution in the mixed shadow mode makes sense if the scene has more than 1.5 million triangles. Otherwise, dynamic mode may be a faster solution. The mechanism of baked shadows offers you a lot of flexibility depending on your needs. You can choose to render baked shadows only or combine rendering of both baked and dynamic ones, keeping realistic look and optimizing performance of your application. For more information on optimizing shadows, please refer to our online documentation.